For number 1, you need to find the range of these. There were many that repeated themselves. You needed to list these least to greatest without any repeats.
Oh, least to greatest.
Least to greatest, always.
I got it correct. Good.
So -5, -3, -2 would be your range.
Oh, wait. Never mind. I got number 2 wrong. I said 1.
That's okay. You can fix it. Questions on the first one? On the second one, it's asking how many solutions does this have. So we would need to distribute 3 times 2x and 2 to get 6x plus 6 minus 3x. Combine your like terms to get 3x plus 6. These are the same on both sides, even though they're switched. They're not in the exact same order. But because they are the same, you could stop there and say this is infinitely many. If you didn't stop there and you kept going, let's say you solved it this way, subtracted 3x on both sides, you get 6 equals 6, which is a true statement. So that would be infinitely many solutions also. Questions on that one? Number 3, we needed to solve this for y, add x to both sides, divide everything by 3. So we would have y equals 1/3 x minus 1.
Why are you adding x?
We need to get x away from 3y, and it's already negative, so we have to do the opposite. So add it.
But isn't x like an indescribable number?
It's a variable. Yeah.
So like
We're not actually adding -3 and x, we're just moving it to the side.
I get it.
The only way to move it is to add it. But we're not actually adding them together. We're just moving it.
Oh! I get it.
Number 4, you need to cross multiply. So 5 times x minus 2 and 2 times x minus 8. Distribute on both sides. From here, it doesn't matter the order in which you start solving this. It also doesn't matter if this was over here and vice versa. As long as once you start solving this, you get -3x equals 6. Divide both sides by -3 to get x equals -2. Questions on that? And number 5, you could have written this one of 2 ways. You're looking for the domain. It has endpoints. So you know you're going to start, you're looking at this least to greatest, so you're going to start at -3 and end at 1. So in your set builder notation with your inequalities, -3 is less than or equal to x, which is less than or equal to 1. Or in your interval notation, back when we were doing inequalities, from -3 to 1, both in square brackets. Either or would work. Questions on that one? Right. Before we start our this unit, look at your course calendar. Make sure you take note of all the important dates, Khan Academy dates, quiz date, test date. What is not on there is your benchmark date. So that is going to be on the 30th, which is a Wednesday. There will be a makeup day before that as well, but I would not wait until then to get retest stuff done. So by that I mean test corrections, additional practice, Khan Academy, Delta Math, all of that stuff done so that you can take the benchmark. Get that done as soon as possible. because this will be the last unit that goes on this marking period. So just to recap what all of those units are, variations, some of you still need to finish that test or take that test. Come get that done ASAP, so that can go in. The unit 6 test that we just took on factoring, and then this unit on quadratics. Okay, so make sure you get all of that stuff in and done, and then if you want to retest any of that stuff, get that stuff done as soon as possible so that when the benchmark comes, you will have the opportunity to take that test. Questions on any of that? Right. We're going to briefly start the notes and then finish them after lunch. But everyone should have notes that look like this. Take those out, put them in front of you. Before we actually start this, I'm going to talk a little bit about what this unit is. So this unit on quadratics is something we've kind of been doing, like since last unit. We were factoring quadratics before, we just never called it that. Anything with something to the square power is a quadratic. So we were factoring quadratics, finding the solutions. There are different ways to find solutions, and we're going to talk about a few of those in this unit. There are more than what we're going to talk about ways, but we're not talking about all of them. When you get to Algebra 2, those of you moving on to that, we'll see those other ways because there's a whole unit on quadratics. So we're really just going to be touching on the basics, on how to solve quadratics and find solutions and graph it and stuff like that. So the first way we're going to talk about how to solve quadratics is using the square root. If we are solving by square roots, one thing needs to happen for certain. Usually your quadratics are trinomials in the form ax squared plus bx plus c, the trinomials we were factoring before. That's not always the case, but in this method, we cannot have a bx. We can't have that middle term. If we have that middle term, we cannot use this method. So if we don't have a bx, then we can continue with this. So we would first need to isolate the x squared, so get the x squared by itself. How would we do that? Add 49 to both sides, so I'm going to rewrite this. We have x squared equals 49. Also, I see some of you not paying attention already. A lot of you go into the units not paying attention. Make sure that you're focused and paying attention so that you understand all of the information. Okay. The second step is to take the square root of both sides. So this is kind of going back to the factoring when we were talking about what times what would give us x squared, what times what would give us 49. So what times what would give us x squared? X and x, so we'll just put x. At this moment, if you don't have your calculator, go grab it. be using a calculator, not the phone calculator. That way you get good practice. Right, so when we take the square root of 49, let's say you don't know what that is. Many of you may. On your calculator, you're going to hit second x squared to get your square root button. And then whatever you need, you're going to put it in. So with these, yes, the square root of 49 is 7. However, we're also going to be talking about the negative version of this number. We know 7 times 7 is 49. Then the negatives is also true. Negative 7 times negative 7 is also positive 49. So when we write these answers, we're going to write both the positive and the negative version of this number. And then the very last thing we have to do is put this in a solution set. We're going to say x equals, in curly brackets, least to greatest, negative 7, 7. Sam?
Do you always put the negative in that number?
Yes. For these, you will always put the negative, yes.
Why?
Just like what I said earlier, because negative 7 times negative 7 is also positive 49, all of them will have that same thing. Any other questions on that before we move on? We'll do one more and probably stop. For number 1, same thing. We would need to add 16 to both sides. So we have x squared equals 16. And then take the square root of both sides. The square root of 16 is what? 4. So this would be plus or minus 4. And then our answers would be negative 4 and 4 in curly brackets. Really quickly, walk me through how would I do number 2? Add 100 to both sides. Root of both sides. We get plus or minus 10. And then write it in your solution set. Negative 10. When we come back, we'll do some more examples. But how do we feel about this so far?
Yeah.
Good. It only gets a little bit harder than this.
You always put the answer in
Let's pretend that didn't happen. Okay, for number 3, solve this just like the other ones, except this one is a plus, so we're going to subtract. In your calculators, put the square root of negative 25. Tell me what happened. Correct. You're supposed to get an error. We cannot take the square root of a negative number. There will be something in a later class where you can do this. There'll be something in a later class where you can take those and do something with them, but not now. So anytime you get a negative, we're just going to say it's no solution. It doesn't work. There actually is a solution, and you'll work that out in like algebra 2. but we're not doing that in this class. You can put a 0 with a line through it, or just put no solution. Either or. So anytime you get a negative, no solution. Always. Is it okay? Are they okay? Questions on that? Other questions on that?
What's a good way to remember that?
To remember that you're going to get no solution, put it in your calculator, and that should tell you. So when you get that error message, oh yeah, it's no solution.
So what's a good way to kind of remember that? Like if you get an error and you're like, oh crap, what am I supposed to do?
If you get an error, that means there was a negative and it's no solution. That's the only time you should get no solution unless you put a negative in by mistake. So be careful with that. Let's turn number 4, subtract 7 on both sides. 81 is a perfect square, so we can take the square root of both and get what? 9 plus or minus 9. So that would be negative 9 and positive 9. Okay, we're going to skip to 6. We're going to do 5. We're skipping 6. Here we're going to subtract 7 on both sides. What happens when we do that? Becomes a negative, which means what about our solution? It's no solution. So as soon as you see that you have a negative over here and your x squared is isolated, you can immediately jump to this is going to have no solution. You could go ahead and put it in your calculator, do the square root of negative 3, but you'll get that error message, which would also tell you it's no solution. Skipping to number 7, we still need to isolate the x squared. How would we do that? Okay. Divide both sides by 6. So x squared equals 9. 9 is a perfect square. So x equals plus or minus 1, 2, 3. So x equals negative 3 and positive 3. Let's skip to 9. 9 also has something by the x squared, but it has a fraction. So normally we would divide that number, but if we were to divide this number here, we'd have a fraction within a fraction. To avoid that, we're going to take this fraction and flip it and multiply it by 4 over 3 on both sides. Just in case you don't remember, in your calculator, if I do 12 times and then put alpha y equals to get my fraction bar, the first one, then I can put in 4 over 3 to get my answer. So x squared, bless you, equals 16. Take the square root of both sides. And x equals plus or minus 4. So negative 4 and 4. Yeah.
Can you show me how to do?
So I have my 12 and I'm multiplying. And then alpha y equals, you get your fraction, and then just put that in, 4/3.
We're going to do number 10 next?
Yes, we're gonna do that next.
Okay.
Go ahead.
I just going to add 5
We would add 5.
and then multiply by 2 over 1.
Yes. Before we do that, I just wanted to mention, if you were thinking multiply by 2 first, in this case, this would be fine, but you would need to do it here, here, and here. Do it to everything. When that would possibly not be okay is, let's say you had a fraction and it was like 3/4. So then you're trying to get rid of this fraction by flipping it and multiplying it. So now you're multiplying by something over 3. And when you multiply it here, you get something over 3 and something else over 3. So you get not nice fractions. That might make it more complex than you really want it. So to avoid that, yes, get rid of this term first. Add 5. And then flip this, multiply by 2 on both sides. So x squared equals what? 100. 100 is a perfect square. You can take the square root of both sides. And x equals positive and negative 10. I did skip writing the plus or minus 10 just because I didn't have space, which is fine for you to do. Go from this step to this step, that is fine. Sometimes you may still want to write it out just to make sure you have the right numbers. Do we have any questions on how to do this before we flip to the back? On the back. So we are going to skip to number 16 and start this process. Add 16 on both sides. And then divide by 9. In this case, we're going to get a weird fraction that can't be simplified. When you get something like this, check and make sure this first before you do anything else. If this cannot be simplified and these are not perfect squares, you would take the square root of this fraction, whatever that is, you would do that. We'll talk about that here in a second. But if these are perfect squares, like 16 is, 9 is, when we take the square root of both sides, taking the square root of this fraction would be the same thing as taking the square root of 16 over the square root of 9. Which would be what? 4/3 plus or minus. So we have negative 4/3 and positive 4/3. Yeah, somewhere. Let's figure out what it is. Okay. Questions on 16? For 17, it's a similar process. So add 1. Divide both sides by 4. Are these both perfect squares? Yes. 25 is, 4 is. So this would give me what fraction? 5/2. Now some of these will give you fractions that you can simplify. So if you're not sure, put it in your calculator as a fraction, because your calculator will give you the simplest version of that fraction. Yes, this is connected. Number 18. How will we start solving that? Subtract 16 on both sides. And then what? Okay. And then what? Not. So if it's not a perfect square, we're still just going to take the square root. And what would that be? An error because we have a negative. So at any point you could have stopped. After you got this negative, dividing by this positive number is not going to change that we have a negative on the other side. So at this point you could have stopped and said, okay, this is going to be x equals no solution. Or waited till you got down to the end, put that in, and got no solution. We're going to do 4 more and then 6 more and then we'll stop. For 19, 19 is already isolated. So the next step would be take the square root of both sides. 19 is not a perfect square. So when we do this, we're going to get some decimal. That's okay. So we're going to put in this square root of 19. It's going to give us some decimal. And we're going to use 3 of these three decimals after the decimal place. So 4.359, positive and negative. So you will get decimals sometimes, yes. Say that one more time.
It's okay to do 4.3.
Use at least 3 decimals.
The 8 bumped up, she rounded it up to 359 because that's calculated right at 0.3.
So you can use all of them. You can use more than 3, but you should have at least 3 decimals. And then you can round that last one. Number 21. Subtract 5 on both sides. We have x squared equals 12. 12 is not a perfect square, but we can put it in our calculator and find the decimal. I will say be careful, because now that you know that you can get fractions, you can get decimals and whole numbers, you may solve it incorrectly and get the wrong decimal, fraction, whole number. Be careful with that. Because all of these are valid answers. You wouldn't really know unless you went back and double checked your work. $22, how would I solve that? Right. We have 2x equals 126. Divide both sides by 2. So x squared equals 63. Take the square root of both sides. And tell me what you get. 7.937. 7.937. Do you have any questions so far, Marta?
Is the majority of the answers going to be in decimal form for the test? Or like, what's the ratio of like whole numbers to fractions to decimals?
I'm going to be honest and say I haven't worked out the answer key yet. And I want to say it's half and half, but that could be wrong. It could also be majority whole numbers, but that could be wrong because I haven't worked out the answer key yet.
If you want to go like 3 root 3 on, like, factor out 63, square root 9, and pull it 3 out, and probably do that.
No, we're not simplifying radicals now. So if you know how to simplify radicals, don't do that here. Just figure out the decimal. If you have no idea what I just said, don't worry about it. Right, 24. You would add 6 to both sides. Here we have a negative, but 8 x squared is not by itself, so we could get rid of that negative. So don't rule it out as no solution yet. Divide both sides by -8, and we get 3, and it's positive. So because we have a positive number, we will get an actual answer. Take the square root of both sides and tell me what you get. 1.732. Three more, and then we will be done working up here together. Then you'll have time to practice. For 26, how would we solve that one? Add 1 to both sides. And then multiply by 5/4 on both sides. In your calculator, you could do 8 times 5/4 to get 10. Then take the square root of both sides and tell me what you get. For 27, there are two different ways you can go about doing this. You could distribute the 3/4 and then solve it like that. Or, because this is on the outside, you could get rid of that fraction by taking this, flipping it, multiplying it to both sides. And that's going to work nicely because when we take it and flip it and the 3 is on the denominator, 6 can be divided by 3, so we're going to get some whole number. So let's take this and flip it and multiply it to the other side. 6 times 4/3 will give you 17. And 8 plus 17 is 25. Back to 25. So we're back at a perfect square. So that would be 5 and -5. We're not doing it. Okay. Overall, how do you feel about this? Good, thumbs up. Okay, sideways, not good, thumbs down. Okay. Alright, there are specific ones I want you to try. The ones I have to start on here disappeared. On the first page, numbers 6, 8, 11, and 12. Circle them, star them, something so you know to go back to those. 6, 8, 11, and 12. And on the back, numbers 13, 20, 23, 25, 28, and 30. I know that was a lot. I'm going to repeat them. 13, 20, 23, 25, 28, and 30. Work through as many of those as you can, all of them if you can. If you have questions, please ask. If you want us to check them, please let us know. But you guys have this time to work. These are also missing some of the work and steps, so make sure you have all of those works, all of the work and steps. So 6, your final answer was -1 and 1. This is also not in the order that I want you to write it in, least to greatest. 8 was -7 and 7. 11 was -12 and 12. And 12 was -2 and 2. Do we have any questions on those 4? And then on the back, 13 was -6 and 6. 20 was the decimal, -6.403, I think was the third one, and 6.403. 23 should have been a fraction. I did just find this out. We were separating this, but you could put this in altogether as the square root of 100 over 36. And it'll simplify that fraction for you and take the square root of both at the same time.
What was that for?
23. So if you do get that, where they're both a perfect square, you can put that entire fraction in your calculator at the same time underneath the square root, but put it in fraction form, otherwise you'll get a decimal. So negative 5/3 and 5/3. 25 was negative 6 and 6. 28 was negative 8 and 8. And 30 was negative 6 over 5 and positive 6 over 5. For the remainder of class, you can do any of the practice things I said before, so the rest of the practice problems in here. You have one Delta Math that is due next class, so by Friday, you can work through that. You have 3 Khan Academies due on Friday. I'm going to briefly explain what the difference is. They're all relatively the same thing, except one is like putting the steps of what you do, like add 5, take the square root of both sides, get your answers. It's giving you the steps and you have to put them in order. The second one, so that's with steps or strategy. It's one of those two. The other one is like so-and-so solved this. Which step did they make a mistake? And then the third one is actually solving it, getting an answer. So make sure you work through all 3 of those. Let me know if you need help with any of those. Come see me before or after school to get one-on-one help with that. And then if you still need to finish a test, take a test, or work on test reactions, come see me before or after school today, tomorrow, before school on Friday.